we are getting started now with show number 8 of the Shock Show. Today, I'm going to be discussing why the measurement of the capacitor of a piezoelectric transducer, and we're especially talking about a crystal, is not affected by a sample holder. And sample holders, give me 1 second, I'm going to bring a sample holder over. All right, so let's pop open a sample holder. Your piezoelectric material that you're going to put in the sample holder, it's going to be loaded, right? There's going to be some push on that that device, and depending on that contact, you're going to have some interference and error introduced into that measurement. And typically, we know that we're supposed to clamp your piezoelectric material at the nodal point. But sometimes, for example, if you're measuring a thickness resonator, that becomes quite difficult. So getting the very low contact forces becomes extremely important. And especially for very small elements, this can be concerning, depending on how much, if your sample holder is this large, measuring a small element can be troublesome. So there is a definite effect, and especially for high Q materials, the sample holder, any amount of damping is going to diminish the amount of Q, the quality factor that you're going to be able to measure. So one thing to do in this case, obviously, to improve the sample holder, do different studies and design of experiments and try to improve the contact and basically lower the effect of the sample holder on constraining and damping the movement of the piezoelectric material. But one thing one measurement, a very useful measurement that the sample holder does not affect is capacitance. So the sample holder has a very low impact on the measurement of capacitance of an ultrasonic transducer, meaning a piezo crystal. And the reason for this is because capacitance at low frequency, there is the dominant factor leading to the response of a piezo is the stiffness. So we have the intrinsic dielectric response or the clamped capacitance contributing to the behavior, but we also have the mechanical movement of the piezo also causing polarization, therefore adding another aspect to capacitance. But capacitance isn't just, we know it's not pure mechanical action, but it is significant, does have a significant contribution from mechanical motion. So it does have that content, that information on it. So a soft material generally will always have, a soft PZT will have a larger capacitance. One reason being there is more movement, but not the only reason. So why does a sample holder not affect capacitance? So this is especially interesting for applications where there are elements in use where the sample holder does provide a large effect. That might be if you're more concerned about thickness resonance, or perhaps if your sample is really small and you have a high Q material, you might be concerned about the effect of the sample holder on your device. But the sample holder does not affect capacitance measurements because at low frequency, the response is governed by stiffness only. It's not governed by mass. So at resonance, there is a resonance between mass and stiffness of the elastic structure. Sound waves moving, there's mass and stiffness involved, but at low frequencies, the dominating factor is stiffness. And because the mass, it's not difficult to move mass at low frequencies, but at high frequencies, higher than the resonance frequency, now the stiffness portion has essentially been frozen out, and mass is now the dominating factor actually governing the motion. So at low frequency, this stiffness, the blocking force of the piezo is very large. It's much larger than something that this little lever can produce. So the blocking force of piezoceramics are very high. So the small forces generated from sample holders opposing the motion may theoretically limit the motion, because there's like a spring in series or in parallel pushing back against the piezo. So the piezo has to push a spring as well as its own internal stiffness when it's expanding, and when the capacitance, the polarization due to the mechanical motion is being produced. However, that stiffness is actually quite small in terms of what the piezo is able to produce in terms of blocking, in terms of force generated. So it has a low effect due to the domination of stiffness at lower frequencies, and the fact that this is actually not that stiff. So the effect on the piezoelectric effect on capacitance, and also the loss factor, the dielectric loss factor, is going to be low. As well as at resonance, there's simply more amplitude and damping occurring at those frequencies. So I hope you learned a good amount from this video. Again, piezo capacitance is not affected by sample holders, so it's a very useful thing to know, and it also brings to light the importance of capacitance, because I believe it's one of the most underutilized parameters by transducer engineers. So thank you for watching this episode of the Shock Show. Please subscribe to this channel, and also subscribe to my blog, where you'll get daily updates on these videos. So see you tomorrow.